Welcome to yet another episode of Projectile Motion. We'll continue doing problems. So here is our next problem. A stone is dropped from some height. Simultaneously, another stone is shot horizontally from the same height. Which stone reaches the ground first? So let's make a quick drawing of this. Okay, so it's dropped from some height over here. Some height h. This is drop. And then you have another stone which is thrown horizontally. So it has been given some speed this way, but from the same height. So we know this fellow is going to go into some sort of a parabolic motion and going to hit the ground over here with some speed. And we also know from our one-dimensional motion that this guy is going to hit the ground over here with some other speed. So if this fellow we call it as, this is stone 1 or ball 1, and this is ball 2. Our question is, which ball hits the ground first? Okay? I want you to first try and figure this out yourself. The key to this problem is the previous problem. In the previous problem, while solving the projectile motion, what we did was we split the two components, perpendicular components, separately and worked out vertical and horizontal separately. Therefore, if you look at the ball's motion, the second ball's motion in the vertical, you will see its initial velocity is 0, the distance it has to travel is h, and the acceleration is 9.8 or g. Don't you see you get exactly the same answer for the first one? So vertically, both the balls are traveling together. In fact, if you were to probe this motion, you would see after some point in time, this ball would have reached here, and this other ball would have reached somewhere over here. A little later in time, when another ball is over here, the first ball is over here, you would see the second ball to be over here. Because vertically, they'll be traveling together. And that's why they're gonna hit the ground at the same time. So that is the answer. Hit at same time. The answer seems quite counterintuitive if you don't really think about vectors. It feels like this guy is gonna take more time. You know what? We can look at extreme cases to see how non-intuitive this is. I could say, imagine that there's a gun over here, which has obviously a bullet loaded, and there's another bullet which I'm going to drop. So I'm going to shoot one bullet over here, and I'm going to drop one bullet. And imagine this is done from some height, and we are in an open field and everything, and we can ask ourselves which of the two bullets is going to hit the ground first. I'm pretty sure your intuition would be something like, well, this thing is going to hit the ground pretty fast, and this fellow is going to go straight and it's going to hit someone, or it'll take a long time for it to hit the ground. But the reality is, if you neglect air resistance and everything, you will see that both of these guys are going to hit the ground at the same time. The only difference is this bullet, which is shot, also has a horizontal motion. It also has a horizontal speed, but that horizontal speed has nothing to do with the vertical. Vertically, they're traveling together. As non-intuitive as this may sound, you need to try and make this a part of your logic to understand projectile motion. Let's quickly go to the next question. Here is question number 2. A ball is projected from a height of 20 meters with a speed of 20 meters per second at 30 degrees to the horizontal. Find the maximum height reached from the ground, the time of fall, range, speed of fall. Okay, so let's do it. Calculate at what speed it's going to hit the ground. So we need to find this. Alright, so are you ready for this? Let's begin. The first step to solving this problem, remember, is to decompose. We're going to be choosing right direction as positive because along the horizontal it's pretty much going towards the right. And if you look at the vertical motion, you see this is like a projectile thrown straight up along the vertical. It goes up and then it comes back down. So I will choose upwards as positive. You are free to choose whichever direction you want to be positive, but I'll choose upwards and positive. And we will need this point as well, so let's mark some points. Let's call this as A, B, and C. So since we have our diagram set up over here, let's do the problem on a fresh page. Okay, remember, I always like to start with the horizontal. Whether I can do it or not is a different story, but I always like horizontal. Alright, what is the velocity in the horizontal? Well, you see the velocity is not at all in the horizontal or in the vertical, it's at an angle, but we know how to decompose vectors. So what we will do, we'll take its component along this side, that's going to be 20 cos 30, and the vertical would be 20 sin 30. And I'm not going to write the values here because it's going to become too crowded. So anyways, we now know that the initial velocity in the horizontal is 20 cos 30, which is 20 root 3 by 2, which is 10 root 3. Okay, what else do we know in the horizontal? Well, first of all, I need to know from where to where I'm doing the physics. I'm doing it from A to C because I want to calculate the range. So this is from A to C. And I don't know the time it takes and I don't know the range, so I can't do anything. The only equation I have is S equals ut, and I can't do anything. So I stop over here, maybe I'll come back later. Okay, now let's start in the vertical. And the first question will be, or first thing we'll try to calculate is the maximum height. So to calculate the maximum height, I'm pretty sure you understand we have to do the physics from A to B. So here is the initial and here is the final. Let's find out what's the initial velocity. Its initial velocity is 20 sin 30, that's over here. So it's 20 sin 30, which is going to be 20 into half, which is 10. We also know what the final velocity is. That's the velocity at the highest point. Notice that in reality the total velocity is not 0. The total velocity is 20 cos 30, but the vertical component becomes 0. So vertically the velocity is 0. And what else do we know? We know acceleration. Notice I took upwards positive, so acceleration becomes minus g, which is minus 10 in all our problems. So we can now use v squared equals u squared plus 2as. So 0 equal to u squared, which is 100, minus 20s. So if you solve this, you get s as 100 by 20, which is 5 meters. There we have it. So what we have found out is distance from A to B, this height, vertical, is 5 meters. So this is 5. Since we already know that this is 20, that means the total distance should be 25. So we have found out our first answer. Height is 25 meters. Ta-da! Our next question would be to calculate time taken for the entire fall. So I'm going to now recalculate vertical motion, but we have to now do this in from A to C. We redo vertical. In the vertical, we go from A to C. So we know the initial velocity, that is 10. The acceleration is minus 10. And what else do we know? Let's see. We know the displacement from A to C. Vertical displacement is minus 20. So S is minus 20. Therefore, since we also want to calculate final velocity and time, I'm going to calculate final velocity first. I'm going to use again v square equals u square plus 2as. So v square is u square, that's 100, plus 2 into minus 10 into minus 20. So v square is 100 plus 400, which gives you v as square root of 500, which is 10 root 5. So we have found out what the velocity in the vertical is. That is 10 root 5 over here. However, that's not the total velocity. It also has a horizontal velocity. And remember, in the horizontal, the velocity never changes. So that always remains. That's 10 root 3. So its total velocity, which we can do it over here now, is the Pythagoras, is the square root of this squared, that's a 300, plus 500. And that will be equal to the square root of 800. I can keep 400 inside, outside, so that's 20. And what remains inside if I take 400 out? So 2. So 20 root 2 is going to be the answer. So the net speed is 20 root 2. That's the speed of the fall. And now I can use this to calculate the time taken. Ooh, by the way, did you notice? There's a v squared. That means I have to be careful. There are two answers, positive and negative. Look, it's downward, so the real answer for our v is negative. I totally forgot to talk about that. Thank God I remembered, because that's going to affect my next problem. See, I'm going to calculate now time taken, and I'm going to use v equal to u plus at to calculate the time from A to C. So v is minus 10 root 5. So please be very careful with your signs. Don't neglect it just like how I did now. Plus 10 minus 10t. So minus root 5 is 1 minus t. And you can bring t on that side. You get 1 plus root 5. There we have it. We have now found the time of fall. There it is. It is 1 square root of 5. Finally, we can go back to the horizontal and finish the problem to calculate the range. Well, I lost my paper for the horizontal, so I'll have to do it again here. So I'll go to horizontal again. And I'm doing the physics for the horizontal from A to C. And that's not going to take much time because I know the initial velocity, we already calculated that. It's 20 cos 30, and that is 10 root 3. And I now found out what the time taken is. That's 1 plus root 5. So all I have to use is s equal to ut. So s turns out to be u, that is 10 root 3, into t, 1 plus root 5. So that gives you 10 root 3 plus 10 root 15. So we have all the answers now. The range turns out to be 10 times, what is that, root 3 plus root 15. Ta-da! I hope this problem gave you some insight on how we calculate seemingly complicated stuff, but by using just one-dimensional analysis and vectors. See you next time, and we'll do some more problems.